Lesson 2-9A. This is going to be day 1 of weighted averages. So we're going to focus today just on mixture problems. So weighted averages, represented by the variable m, is a set of data that is found by multiplying each data value by its weight and then finding the mean of the new data set. With mixture problems, these are problems in which 2 or more parts are combined into a whole. Sometimes mixture problems are expressed in terms of percents. So this first one that we're going to work with is just going to be with dollar amounts. So it says a tea company sells blended tea for $25 per pound. To make blackberry tea, dried blackberries that cost $10.50 per pound are blended with black tea that costs $35 per pound. How many pounds of black tea should be added to 5 pounds of dried blackberries to make that blackberry tea? So, it seems like a lot, but what I like to do is I like to create these data tables. And in these data tables, what I do is I write down what are the units that we're working with, and most of the time it's just gonna be 2 different units. And because we're dealing with price, I'm gonna have a total column, and in this case, it's gonna be the total price per unit, okay? Meaning how much are they gonna spend all together. Then what I like to do is think about what are the things that are being combined together in order to make our mixture. So in this case, what I've recognized is that there are dry blackberries and there is black tea that they are going to blend together in order to make this blackberry tea, okay? So now what we need to do is we're gonna start plugging in things into this table. Like I said, the table is something that I like to use because I'm a very visual person. If the table is too confusing, by all means, don't use it. So if we look at the first sentence, it's telling me that this tea company is selling the blended tea for $25 a pound, okay? So remember, my last row that I have here is my blended tea. So since it's $25 per pound, I'm gonna put 25 in that box right there. The next sentence says, in order to make the blackberry tea, dry blackberries are costing $10.50 per pound. So our dried blackberries are $10.50. And they're blended together with black tea, which costs $35 per pound. It's asking how many pounds of black tea. So right there, there's your unknown, which is why if you looked at step 1, it's telling you that W, and if you don't want to use W, that's totally fine. W should represent the weight of the black tea. So if we're trying to figure out how many pounds of the black tea, we're gonna put a W for black tea. So how many pounds of black tea should be added to 5 pounds of dried blackberries? So we know that there are 5 pounds of dried blackberries and that they are being added together to make your blackberry tea. So to represent your combination, we need to take the dry blackberries and we need to add the black tea in order to know how many pounds our combination is going to have. Once we do this, now what you do is that when you go to the last column, notice that it's total price, which means that you're gonna take the number of pounds times the price per pound and figure out your total. So for the dry blackberries, we'd be taking 5 times 10.50. For the black tea, we would be taking W times 35. And then for our blackberry tea or combination, 5 plus W times 25. So since we're making a mixture, our mixture is going to take our dry blackberries plus our black tea, and it's going to be equal to our total combination mixtured tea. So to write an equation, we're going to do 5 times 10.50, which is the total price for the dried blackberries, plus the price of the black tea. And then we're going to set it equal to the mixture. Okay, so now that we're here, there's your equation. Now you're going to solve. So 5 times 10.5 is 52.5 plus 35W equals, and I'm going to go ahead and distribute that 25. Now I have variables on both sides. Oops, sorry about that. All right, so what I have figured out when I solve for W, I am figuring out how much of the black tea needs to be added to the dried blackberries in order to make this blackberry tea. All right, we're gonna go ahead and jump ahead. All right, and we're gonna go to example 3 because example 2 is very similar to what we just had in the last problem. This time the table's not filled out, so we'll fill that out together. So for example 3, it says how many pounds of premium coffee beans should be mixed with 2 pounds of supreme coffee to make the blended tea. So for this one, you have to use the picture down at the bottom because that's giving you the price per pound. So right there, they're giving you your units, right? We have pounds, which I'm just gonna use the unit abbreviation, LBS, okay? I have my cost, and then I have my total. And so we have premium and supreme are the two different coffees that are being put together in order to make our blended tea, or coffee, excuse me. So now that we're here, it's saying how many pounds of premium? Well, there's your unknown. So you should label that X equals number of pounds of premium coffee. So since premium is our unknown, should be mixed with 2 pounds to make the blended tea. So this is just like the one we just did. We're taking premium plus supreme to get our blended. So we have X plus 2. Okay. The price, we're gonna take the prices that are in the picture. So $9.50 for the premium, $11.75 for the supreme, and $10 for the blended. So now we're gonna get our total. So we're gonna multiply across 9.5x or 950x, whatever you'd like to do, 2 times 11.75, and then 10 times x plus 2. So remember, the premium and the supreme are being added together to make your blended. So we have 9.5x plus 2 times 11.75 equals 10 times x plus 2. I'm gonna go ahead and now solve. So I have 9.5x plus 2350 equals 10x plus 20. I'm gonna go ahead and move my terms around. So subtract 950x, subtract 9.5x, subtract 20. And for this one, X equals 7 pounds. So they would have to have 7 pounds of the premium in order to make this blended coffee. Okay. So for the food, this one here, probably a little bit easier, but so we have soup and salad. We have 10 ounces of soup and the total is $3.50. How many ounces of salad did she order? Okay, so we have price per ounce. So I'm gonna go ahead and write my ounces, price, total. And now I have soup and I have salad. And now you have to think with this problem, we're not gonna take soup, hopefully, and pour it into our salad to make a mixture. If you do that, that's on you. But in this one, we would not have a mixture column here, okay? So we know that there is 10 ounces of soup, but we're trying to figure out how many ounces of salad. So that's your unknown. X equals ounces of salad. The price for soup is 15 cents. With money, don't forget to write it as a decimal. For the salad, it's 20 cents. And then same idea, I'm still gonna multiply across. So 10 times 0.15, X times 0.20. But now with this one, we just know that if they get soup and salad together, the total price will be $3.30. So we're still not necessarily combining them together, but we're just trying to get the cost. So we're still gonna do 10 times 0.15 plus X times 0.2 equals 3.30. So for the first one, I have 1.5 plus 0.2x equals $3.30. I'm going to subtract 1.5 from both sides. 0.2x equals 1.80 divided by 0.2. I get that x equals 9 ounces. Okay. So now the next part that we're going to do deals with percentages. Okay, so for this one, it says Mrs. Matthew has 16 cups of punch, that's 3% pineapple juice. She also has a punch that's 33% pineapple juice. How many cups of the 33% punch will she need to add to the 3% punch to obtain a punch that's 20% pineapple juice? Lots and lots of punches. So for percentages, you really have to make sure that you're writing those down, especially because those percentages are going to be part of your problem. So we know that Mrs. Matthews has 16 cups of punch, that is 3% pineapple juice. So the table's already labeled for you. Notice how instead of like what we had with ounces, money total, I'm doing percentage, I'm doing the amount, and then the total. So if you wanted, you could do like mix 1, mix 2, total, if that helps you to identify the different percentages. So for 3%, I have 16 cups. She also has punch that's 33% pineapple juice. How many cups of the 33%? So just like before, they're giving you this variable, which you need to add to the 3% in order to make this mixture. So just like we did with the previous ones, we are gonna take the amount of cups of the 3% plus the 33% cups to make our total. For the amount of pineapple juice, this time we're gonna multiply across, but since this is 3%, all percents need to be written as decimals. So I have 0.03 times 16. I have 0.33 times x. And then I have 0.2 times 16 plus x. Same problems. This plus this equals that. Probably should have put the plus sign a little bit higher. Okay, and so now what we're gonna do is we're gonna write the equation and we're gonna go ahead and solve. So 0.03 times 16 plus 0.33x equals 0.2 times 16 plus x. All right, I'm gonna go ahead and solve. So this would be 0.48 plus 0.33x equals 3.2 plus 0.2x. I'm gonna go ahead and move things around. So for this one, if I divide 2.72 divided by 0.13, I get 20.9 cups. Okay. So let's see. We're gonna do example 7. And then we'll be done or 7 and 8, and then we'll be done. So for example 7, one type of antifreeze is 40% glycerol, and another type of antifreeze is 60% glycerol. How much of each kind should be used to make 100 gallons of antifreeze? So we have glycerol, and we have or glycol, sorry, and then we have gallons. So we know that we have 40%, we have 60%, and then in total, we have this 48%. So I'm gonna go ahead and write 40%, 60%, and then in total, we want it to be 48%, okay? For gallons, all we know is that there are 100 gallons. So for this problem, there is actually 2 variables. I'm gonna go ahead, because we need to find the amount of each of them, we have 2 different variables here. So I'm gonna note that X is our 40% gallons and Y is for our 60% gallons, okay? So same problem, right? It just looks a little different from here. But what we need to notice is that with our gallons, one kind of equation that we're gonna have is that we would have to take the 40% gallons, the 60% gallons, in order for it to total 100 gallons. Okay, so I'm gonna write that off on the side here. Okay, the other equation that I have is just when the ones where we're multiplying across and setting it equal to our total. All right, so the first one, once again, percentage needs to go to decimal. 0.4x plus 0.6y equals 0.48 times 100. Okay, so now we have 2 different equations we have to work with, and we need to make sure that we solve for both. So what you're gonna wanna do is, and you can do multiple different ways, you've done system of equations before. I think in this case, substitution is the easiest, but if you'd like to use elimination, that is on you. So for substitution, what I'm gonna do is I'm gonna go ahead and solve. First off, I'm gonna take this equation and solve for one of them. So I'm gonna go ahead and just solve for x. If I were to solve for x for this one, x would equal 100 minus y. So now I'm gonna take that and I'm gonna plug it in for x here. So I have 0.4 times 100 minus y plus 0.6y equals, and I'm gonna go ahead and simplify this out to 48. Notice now, going from this first equation to the second, I have the y values there. They're both y. Now I can solve. When I have an equation that has two variables, I'm not going to be able to just solve for one of them. So I'm going to go ahead and continue to work from here. So I'll distribute. So I end up getting 40 minus 0.4y plus 0.6y equals 48. I'm going to combine my like terms here. So I have 40 equals 0.2y equals 48. I'm going to subtract 40. So now I have 0.2y equals 8. I'm going to divide by 0.2. I end up getting, when I divide those out, that y equals 40. Okay, and it would be 40 gallons. So this tells me the value of y, but since I need to solve for each, I also need to solve for this x. So the easiest thing to do would be just to plug it back into this equation. So I would have x equals 100 minus 40. So then I can figure out that x equals 60 gallons. So now I know that there would have to be 60 gallons of the 40% and 40 gallons of the 60%, right? The last problem, I just want to set up the table just because we haven't had one without anything on the table. So Megan has 40 milliliters of 20% solution. How many milliliters of 60% solution should she add to obtain the required 30% solution? So we have percent and we have milliliters, okay? So with our solutions, and once again, you can use a table or you don't have to. I'm gonna go ahead and just put solution 1, solution 2, and then total. And I know that I'm working with percents and I'm also working with milliliters. So I know that that the first one is I have 40, oops, got them mixed up, 25%, 40 milliliters of the 25%. I am trying to figure out how many milliliters of the 60, so I'm gonna go ahead and define my variable that x equals milliliters of 60%. So I'm gonna go ahead and put that here. This would be 60%. And then I'm trying to obtain 30%. And remember, it's a mixture, so these are gonna get added together. 40 plus x. Okay, so I'm gonna go ahead and have my total. I'll multiply across from here, set up the equation, and then you can solve. So 0.25, because it's a percent, times 40, 0.6x, and 0.3 times 40 plus x. Your equation, once again, solution plus solution equals your mixture. So 0.25 times 40 plus 0.6x equals 0.3 times 40 plus x. Go ahead and finish that problem.